Next one. Tangent of L. Do that one on your own, okay? Find the tangent of L. Give it as both a fraction that's reduced and as a decimal. Actually, what do you have as your fraction?
12.
Good, because 12 is our opposite, 35 is our adjacent. And Emily, what did you get for your decimal? 0.34, okay. Thank you. All right, so we got 3 more. Now we're looking at the sine of n. So what's different? Different angle. So we're now looking from the perspective of n. That's the difference now. But it's still going to be the same stuff. So I'll help you with this first one. What's our ratio going to be for the sine of n? And do we need to recalculate what that is in the decimal? Why not? Yeah, what is it? So that's kind of an interesting thought. The sine of n ended up being the same thing as the cosine of L. So let's see if that happens again. Next one. Cosine of n. What's that going to equal? 12/35, because that's the adjacent. That's the hypotenuse. Yes, I did. Thank you. 12/37. So approximately, we already know that that's going to be 0.32. And then the last one, tangent of n. What ratio is that going to be? Careful. Why did that be 35/12? Right. The 35 is opposite of that one, and this is the one that's right next to it. So we're going to do equals 35/12. We don't have that one already, so approximately, what is it? 2.92. Thank you. And that's how you find Trig ratio. Any questions at all? Feel pretty good about doing this on your own? Yeah. Practice some more though, a little bit. Example 2, you want to write that down. I want you to, after you have it written, draw a figure and think about how we could do this one. I want you to try to come up with some kind of a plan. Combine what we did last time with what we're doing right now. We're going to use a special right triangle to express the cosine of 60 degrees as a fraction and a decimal. So which of our 2 special triangles from last time do we have? Yep, 30, 69. Did you draw it yet? That'd probably be the first step. We're just going to estimate what that might look like. Our 60, our 30, and our 90. Now we want to find the cosine of 60. But to be able to make these ratios, what do we have to know? Some sides. Could we make some up? Yeah. What can we make up?
The short side be like 12.
Okay.
So that means that so the hypotenuse would be like
Okay, Grayson's on here. We can make up the short side to be whatever we want. That 12 we could do. Could we make it even easier on ourselves, though? Use 1, maybe? If this is 1, what's the hypotenuse? 2. If this is 1, what is the longer leg? 1 radical 3 or just radical 3? Now, there's nothing wrong with what you were saying using 12. You just would end up reducing down at the end. So that would have been fine. But you just make up a short side length, use the rules to find the others. So now, can we find the cosine of 60? Okay, what are we going to do? What did cosine mean? Look back. Right, because they SOHCAHTOA. C-A-H. So adjacent over hypotenuse. And actually, what did you say? Okay, this is our adjacent side. This is our hypotenuse. So we can write the cosine of 60 degrees equals a half. So as a decimal, what's that going to be? 0.5, and no need to round. Let's verify that on your calculator. I know it looks like a lot of you have different calculators, and if you need some help finding where these buttons are, I'll help you out. I know like the Texas Instruments ones, you have to type in the angle and then your cosine key. If you're using the Casio ones, you type in this cosine key, then the angle, and hit enter. So try to type in cosine of 60. And if you need some help, call me over. And you should be getting what we just found. Anybody, and ask now, please, so I'll make sure you know how to type this in. You need to see how to type it in if you're not getting 0.5. Okay. Which one are you using? One. Okay. Okay. That's fine. So everybody's got it? All right, cool. Usually that doesn't work. Next one, just draw that triangle and then just write the directions up there. And some info I'm going to give you here. We're going to find y. Y is this leg. That's the right angle. This one is going to be 7. And this, we're going to change that a little bit. Apologies if you already wrote it. We're going to make the angle 7. So that angle inside of there is 7 degrees. And then I'm going to make this side up top, which would be the hypotenuse, 5. So what we've got a right triangle. I know the hypotenuse. I don't know either leg, but I know an angle. Could we have solved this before? Could we have used Pythagorean theorem? Why not? Yeah, we only know one thing. I don't know another leg, so I can't do that. Could I have used my special triangle? Why not? Yeah, it's 7. It's not 30, 60, 90. It's not 45, 45. But we can use our trig ratios. So when you've got one like this, the thinking part is, what do you know? So first of all, look at your angle. Compared to this angle, what would you call the y? And then we also have the, so what trig function fits opposite hypotenuse? So here's how we're going to set this up. I know the angle, so I'm going to say that the sine of 7 degrees equals, what's the ratio going to be? Y over 5, because that would give me the opposite over the hypotenuse. Now from here, we just got a little bit of algebra. I want to get y by itself, so how do I do that? Take both sides times 5. So that cancels. So y equals 5 sine of 7 degrees. This is why I wanted to make sure you got to type that in your calculator, because that's what you're going to do now. You're going to type that in as you see it. If you're using the TI ones, you might have to do a little bit backwards. You'll probably have to do 7 sine, and then take that times 5. If you're using the Casios, you just type it in as you see it. That's one reason I like those a little bit better. They're a little bit more user-friendly. And let's just go nearest hundredth. Now, again, I really want to make sure everybody's got this, because you're not knowing how to type this in. You're not going to be able to do much of the homework. So do not hesitate to ask. What are y'all getting? 0.61, which is right. So y is approximately 0.61. Does that seem like a valid answer? It's pretty small.
Yeah.
Why does it seem valid? Yeah, if you look at that angle, I mean, that's a really small angle. So this side's 5, and it's across from the 90. That side's going to be way smaller than 5. So that seems like a legitimate answer to me. Austin, did you figure it out? Okay, anybody else need help typing in? Does it hand up? No? All right, cool. Next thing, inverse trig functions. Inverses, we use these all the time. We just used one recently when we were talking about getting rid of the square root. What was the inverse of our square root? Squaring both sides. And when you use inverses, what do they do to each other? Cancel out. So it's a way to get rid of something. So this is going to be ways to get rid of the trig functions. We're going to do that in an example. We'll label our triangle as Q, R, P. R is our right angle. RP is going to be 13. QP is going to be 19. And again, as the directions say, we want to find out what is the measure of angle P. And as you're writing, be kind of thinking about, well, we could not have solved this before. Okay? I don't know that the sides are congruent. I only know one angle, so I don't have any other way to find out the other two based on our previous knowledge. Using what we've got today, we can figure this out. Just like our last example, you've got to look for which trig function fits the information that you got. So we want to find P. How do the sides that we have relate to angle P? 13 will be adjacent. 19 will be hypotenuse. So what trig function fits this? Cosine. So here's what we're going to write. Cosine of angle P equals, what's the adjacent side? Over 19. This is where we need the inverse, because right now P is part of that cosine function. I can't just divide by it, because cosine by itself, that's not a number, it's an operator. So to get rid of it, I'm going to take the cosine inverse of both sides. And the way we're going to show that as P equals the cosine inverse, a little -1, of 13 over 19. It's the same kind of idea that we always have in algebra. If we've got some kind of operator that we need to get rid of, we do the opposite. And usually it's called something different, but with the trig stuff, it's literally called the inverse. But just like earlier, to get rid of our division, we multiply. So to get rid of our cosine, cosine inverse. And then that cancels out on the left. I've got that on the right. Now it's a calculator problem. Look at your calculator. Find the cosine inverse. On most of them, it's going to be like second. That. Yeah, Matt. What? Okay. I don't even know it yet, so give me a second. Let everybody kind of look for it for a little bit. So notice I didn't write parentheses up there. You're probably going to want to do that on yours as well. So cosine inverse, parentheses, 13 over 19, close parentheses, enter. Matt, what would you say you got? Okay, 46.8. And let's just go tenths like it says. So P equals 46.8